Block A is placed on block B, whose mass is greater than that of A. There is a friction between the blocks while the ground is smooth. A horizontal force P increasing linearly with time begins to act on A. The acceleration a1 and a2 of A and B respectively are plotted against time t. Choose the correct option from these four given options. So we can only choose when we have critically done the analysis of this question. See, the question is given as there is a block A and this is B, where the ground is smooth and this is having a friction, and we are applying on the block which is having a friction, is P. And we also told that this is time dependent force. See, they will continue to move at a constant acceleration for some time. Say I take some kt. That is because as we go on to increase force P, the friction between A and B also goes on to increase due to its self-adjusting nature. But after a certain point of time, as we all know, friction cannot go beyond this limiting value. It can definitely be less than the value of mu s, because kinetic friction is less than mu s. That means this will definitely, if we take kinetic friction into consideration, this will definitely decrease instead of increasing after a certain value. So they will definitely, both the blocks will move for some time together. So we can say acceleration versus time for both the blocks will be same for some time. After that, the driving force on B is in forward direction, because on A it's in backward direction. The same friction acts on B in the forward direction, and there is no resistance from the floor. So the only force acting on B is by the A. You can write FBA, and it is not going to increase beyond mu mg, which is mu m1g. If we apply is equals to m2a, we get of the second block mu m1g upon m2. That is what we get as the acceleration of block B. So we definitely know that if we are making the graph for block B, it will go constant. It will not increase further. Now, if we talk about the block A, what happens after this certain point has reached where the friction has become mu mg? This is the force P, which is time dependent. The below friction act as A due to B. And however, since this block is also accelerating, becoming a non-inertial frame, this also has to be applied in the backward direction. We can write m1a2, and then we can say having a final acceleration m1a1. Writing all these forces P minus FAB and minus m1a2 as a pseudo force, because the platform is also accelerating, then we get m1a1. So this is kt minus this is FAB is the force mu mg mu m1g minus m1 into a2. That is, you can also write m1a2. I'll tell you why I'm writing like this. m1a2 is equals to m1 a1. So if we find out the acceleration a1, we get kt by m1 minus mu g minus a2. So this is the acceleration with respect to the block B. Okay, this is not the absolute acceleration with respect to ground. The absolute acceleration with respect to ground will be a1 plus a2. a1 is the acceleration of the block A, and we have to add the acceleration of the block B as well, which is a2, to get the absolute acceleration with respect to ground. kt by m1 minus mu g. I hope you are understanding this, because I have already taken one of my examples. If you see in the playlist, you will see variable force acting, and then there's a friction series in this playlist only, where variable force is the name I given to that question. That same question is there. However, here we are working on the graph. So this is the absolute acceleration, and we have to make the graph with respect to the ground. So we need to get the correct expression. You see that mu g will never change after a certain point of time. It is also increasing, and this with time also increasing. So this number will increase for some point of time because the friction is self-adjusting. But after a certain point of time, this stops increasing. So suddenly there is a jump in the acceleration as this stops increasing, and this due to time keeps on increasing. So because why I am discussing this point, because there is another graph which is like this. See, the acceleration is not changing when this limiting value has reached. Huh? This is not doing the correct answer because this value has stopped increasing. So definitely now this will increase and have a different rate of increase in the acceleration. So this is the correct answer, where we have a different rate of acceleration. So this is A1 and A2 as well. Later this becomes A2 and this becomes A1.